Hello, I'm Jeff Hutchins. I work at Renovus. I am in the CTO's office, and I'm also the OIF's co-packaging working group chair. The OIF at the recent meeting launched its new project for the 3.2T optical engine project. This is for data center applications for Ethernet switching. And it covers the optical interfaces such as 400G FR4 and DR4, as well as backwards compatibility for 200G. It also defines the mechanical, electrical interfaces for the chip, including the management interface. What I think is really significant is the OIF started this effort on the co-package framework project last year, and we made pretty rapid progress with workshops and starting this new framework project. And now, 9 months later, we've got our first project addressing the 3.2T optical engine project. As we move forward to new generations of the switch chips, it's getting more and more difficult to be within the energy envelope, the power envelope for these switching systems. And by switching to co-package optics, we can get the optical engine much, much closer to the ASIC. And that allows us to lower power interfaces and keep the overall power consumption lower. To do that, you need very, very dense optical engines. And the co-package project basically specifying the mechanical dimension of something that's quite small and allows us to get, in this particular case, 51.2 T of bandwidth around a co-packaged ASIC. The industries has started out with, there's a JDF between Microsoft and Facebook, where they were working on co-packaging, putting together a document, and also various forums. The COBO started with this effort to do power reduction with their onboard object project that they've started. So this is really the next generation, and it leverages work that a number of people have done in the industry to try to get to this co-package. It's very, very challenging because it involves a lot of new technologies. To use dense optical engines with silicon photonics, high level of fiber attached. The thermal management is very complicated. There's potentially remote laser sources. The laser sources aren't going to be inside the transceiver module. So there's a lot of new things here. So it's a very, very complicated thing touching many different technology areas. The interest in this project is really, in the whole effort has really been stunning. I mean, we have, on the conferences, we have very large attendance, and I think that's partly because of the interest in the industry, plus the fact that it involves all parts of the ecosystem. So there's people from optical connectivity point of view, electrical, thermal, all different parts of the industry are involved in this thing. So it has quite a lot of attendance, and likewise, COBO has been working on this as well, and they've been approaching various parts of the problem. And together, we think that the forums will be able to advance the standards in this area.